about that. So if you go back to this value here, you know it's x plus 1 squared. And negative 1/2 plus 1, or 1 minus 1/2, is just 1/2. Okay. So we have x plus 1 squared equals 1/2. Bless you. Okay, so fourth step, you're just going to square root both sides and solve. Okay. So remember, the square and the square root always cancel each other out. So x plus 1 equals plus or minus square root of 1 is just 1. And square root of 2, you can leave that as square root of 2. And if we just subtract 1 from both sides, x equals negative 1 plus, and a little side note here, if we multiply this one by square root of 2 over square root of 2, 1 over square root of 2 times square root of 2 over square root of 2 equals square root of 2 over 2. Okay. Most of them like when there's no root numbers in the denominator. So if you plug in and you have a square root in the denominator, they usually want you to get rid of it. So 1 plus square root of 2 over 2. Okay. So that just means your x, bring that up a little bit, is equal to, clean that up some. There we go. At negative 1, you can make that negative 2 over 2. Plus or minus square root of 2 over 2, which means you can make that x equals negative 2 plus square root of 2 over 2, or x equals negative 2 minus square root of 2 over 2 as your final answer. So sometimes it'll come out to be a nice, neat whole number, or nice, neat, pretty fraction. Sometimes it'll come out to be a strange-looking irrational number. All right. So any questions on that one? All right. Leave that up for a few seconds. Yes.
Writing the 1, 2 over 2 necessary?
No, not really. If you left it as negative 1 plus or minus square root of 2 over 2, that'd be fine. But in some homework, because I know some technology is different, if they say simplify it, they may want you to do that. So that's one of those just in case they ask for it kind of steps. Okay, any other questions on this one? All right. Make sure everyone's done. Yep, everyone's done. Excuse me. Okay, so now we're going to talk about the quadratic formula. All right, so let's say if we decide to let some ax squared plus bx plus c equal 0. Represents some quadratic formula. Quadratic equation. So what we're going to do here is we're going to actually complete the square on this one. Okay, so if you have ax squared plus bx plus c equals 0, we're going to divide every term by a. Okay, and anything divided by itself is just 1. So you have x squared plus b over ax plus c over a. 0 divided by anything is just going to give you 0. Okay, so that was the first step of our completing the square. Okay, remember, our next step was we were going to isolate our x variables. So we're going to subtract both sides by c over a. So x squared plus b over ax equals negative c over a. Okay, so now we're going to complete the square over here. Okay, so you know our a is equal to 1 and our b is equal to b over a. Well, should have used different numbers than a and b, but we'll leave it there for now. Okay, so if we completed the square, remember that would be b divided by 2a squared. Okay, which means since we're using b and we're actually using a, we'll have, well, that's ba over 2, same thing. That'd be, didn't really need the parentheses. B squared over 4a squared. Okay. So that's our completing the square value. Now remember, we're going to get that and we're going to add it to both sides of the equal sign. B over ax plus b squared over 4a squared equals b squared over 4a squared minus our c over a. Because remember, we still had that minus c over a there. Okay. And here, remember, before we apply our square, that value inside of there, remember, we always remember that value? We're going to do the same thing here. So this becomes x plus b over 2a squared equals b squared over 4a squared minus c over a. Okay. So we want to combine these because it kind of looks messy that way. So we're going to multiply this particular one by 4a over 4a. Move that up a little bit. Okay, so we now have our x plus b over 2a squared equals b squared minus 4 times a times c. All over 4a squared. Okay, so now we're going to square root both sides. Okay, so x plus b over 2a, once our square and square root cancel out, that's going to equal plus or minus the square root of b squared minus 4ac all over 4a squared. Okay. Now if we subtract our b over 2a, we have x equals negative b over 2a plus or minus. And remember, with the square roots of a quotient, you can just supply the square root to both of them. So you have the square root of b squared minus 4ac all over the square root of 4a squared. All right, so we end up with x equals negative b over 2a plus or minus square root of b squared minus 4ac. Square root of 4a squared is 2a. Okay. So you can actually just combine those into one equation. That's negative b plus or minus the square root of b squared minus 4ac, all that over the common denominator of 2a. Okay? And that's our quadratic formula. So no, you won't have to do that every single time. All you have to do is use that formula. Leave that up for a few. Okay. All right, so let's say, for example, if we wanted to solve 2x squared minus 5x minus 3 equals 0 using the quadratic formula. And the hardest part about the quadratic formula is remembering the quadratic formula. If you can remember it, it's all downhill from there. Okay, so you have 2x squared minus 5x minus 3 equals 0. So you know here our a is equal to 2. Our b is equal to negative 5. And our c is equal to negative 3. Okay. So using our formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, we just plug it in. So x equals negative b, so that's negative 5, plus or minus the square root of b squared, so that's negative 5 squared, minus 4 times a, which is 2, times c, which is negative 3, all over 2 times a, which is 2 times 2. Okay. So x equals negative times negative is positive, so you have 5 plus or minus square root negative 5 squared, which is 25, minus 4 times a times c, so that's 4 times 2 is 8, 8 times 3 is 12, negative negative is positive, so it's plus 24, all over 4. Okay. So you end up with x equals 5 plus or minus 25 and 24 is 49. Square root of 49 over 4. Since square root of 49 is 7, we know it's equal to 5 plus or minus 7 over 4. So we'll just bring that down here. So that means that x can equal 5 plus 7 over 4 or 5 minus 7 over 4. Okay, so 5 plus 7 over 4, you have 12 over 4, which is just 3. 5 minus 7 over 4, 5 minus 7 is negative 2 over 4, which is negative 1/2. So once you plug it in, it's pretty much just simplifying from there. All right. So any questions on this one? All right. We'll do one more. Make sure. All right, so let's say, for example, if we wanted to solve 2x squared equals negative 4x minus 1. Oh, sorry about that. All right, so for this one, we can't do anything with this one because it has to be in the ax squared plus bx plus c equals 0 form. Excuse me. In the ax squared plus bx plus c equals 0 form. Oh, using quadratic formula. Forgot that part. Okay. So that means if we add 4x to both sides, you have 2x squared plus 4x. If we add 1 to both sides, plus 1 equals 0. Okay. So we know our a is equal to 2. Our b is equal to 4. And our c is equal to 1. Okay, so now we just plug it in. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so now if we plug everything in, x equals negative b, so x equals negative 4 plus or minus the square root of b squared minus 4 times a times c, so 4 times 2 times 1, all over 2a, so that's 2 times 2. Okay, so that means x is equal to negative 4 plus or minus square root of 16 minus 8. 16 minus 8 is 8. So minus square root of 8. Oh, clean that up some. All over 2 times 2, which is just 4. Okay. So if we want to simplify it, we could. So x is equal to negative 4 over 4. Well, might as well leave it like that. Negative 4 plus or minus 8. Kind of simplify that first. Okay. So remember your square root of 8. You can rewrite that as square root of 4 times 2, which is square root of 4 times square root of 2, which is 2 square root of 2. So plus or minus 2 square root of 2 over 4. Okay. So now we can simplify it. Because our x is equal to negative 4 over 4 plus or minus 2 square root of 2 over 4. Negative 4 over 4 is just 1. Oh, negative 1. Sorry about that. and square root of 2 over 2 after you simplify that. And so you can write it either this way, or if you multiply this by 2 over 2, you can make that negative 2 plus square root of 2 over 2, or x equals negative 2 minus square root of 2 over 2. Okay, so if it doesn't take it this way, then you know you have to kind of tweak it a little bit. All right, so any questions on this one? All right, leave that up for a few seconds. Okay. Okay, so now we're going to look at what they call rules for discriminants. Oh, clean that up some. Okay, and your discriminant, the square root of b squared minus 4ac. I guess you could say just the b squared. You don't really need the square root. Okay, so b squared minus 4ac is your discriminant. Okay, so you have 3 different rules for discriminants. Rule number 1, when b squared minus 4ac is positive, there are 2 different real solutions. So if you look at it this way, let's say, for example, if you're using your x equals negative b plus or minus the square root b squared minus 4ac all over 2a, and let's say you go through all of your work and you end up with negative 2 plus or minus, that b squared minus 4ac becomes positive 8. That's not even positive 8. Let's say positive 11. All over 2 times 3, let's say 6. I'll say 2 times 3, whatever it may be. Then that means this will become negative 2 over 6 plus square root of 11. Oh, actually just make that 1 instead of making it more complicated than it needs to be. So negative 2 plus square root of 11 over 6, and negative 2 minus square root of 11 over 6. Okay? So whenever that discriminant is greater than 0, you're always going to have 2 solutions. Okay. Rule number 2, if that discriminant is equal to 0, then you're only going to have 1 solution. B squared minus 4ac equals 0. Let me kind of separate that a little bit. You will have one repeated solution. Okay. You're going to have one solution, but it will repeat itself. Okay, so let's say, for example, if you do all of your, let's say, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and you do all of your work, and you end up with negative b, or not negative b, let's say negative 5 plus or minus, and your b squared minus 4ac became 0. So square root of 0 over 2 times, let's say 6, I'll make that 12. Then what you're going to end up with is x equals negative 5 plus square root of 0 is 0 over 12, and x equals negative 5 minus 0 over 12. So it's just negative 5 over 12, negative 5 over 12. Okay. So if you were to look at that as just being factored, it would look something like x plus 5 over 12, x plus 5 over 12 equals 0. So that's how that would look. So any questions on that one? All right. And I'm running out of room. I'll continue this one on the next page. Leave this up for a few more seconds. All right. Okay, and the third rule. When the determinant is negative, you get two imaginary solutions, or complex solutions. That are complex conjugates of each other. Okay. So, for example, let's say if you again go through all of the x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and you do all of that work, and you end up with negative 3 plus or minus the square root, and that became a negative number. Square root of negative 5 all over 2 times, I'll say 4, and make that 8. Okay. So if you remember your complex numbers, that square root of negative 5 is going to become square root of 5i.